Okay, welcome back to the final exam review for Algebra 2. On this part, so we're still covering section 14, but now we're going to cover the second set of questions here. This section covers cube root functions. So we're going to perform transformations on cube root functions, and fortunately, the same transformations that I mentioned in the last video given by all of this still applies. So if we know how to read the transformations for the square root function, then we also know how to read the transformations for the cube root function as well. So again, I recommend having all of this information handy. But yeah, so let's look at this and let's see what transformations we have. So for those of you who haven't seen the cube root function before, it looks like this. We can go to Math and scroll down to option 4. And if we just hit X and plot this, we have a function that looks like this. So it looks like the square root function, but also with this other branch here. But if we graph the square root function next to it, or overlay it with one another, we see that the square root function is a little bit taller. And that's because the square root function, for example, the square root of, we go to our graph here, notice that both functions go through 0 for x is 0, and they both go through 1 for x is 1. However, the square root of 4 is 2, but the cube root of 8 is 2. So that's why the cube root function is flatter than the square root function uh, because we're taking a cube root, it's going to return a smaller number. So the square root of 4 is 2, but here the square root of 4 is, the cube root of 4 is 1.58. But if we take this number and we cube it, we'll get back to 4. And same thing over here. If we take the number 2 and we cube it, we get to 8. But we have to take the number 2.82 and square it to get to 8. So that's why visually the cube root function is flatter. But yeah, that's just to compare the two. But for the purposes of this video, we're going to work with just the cube root function, which again is just that one. So all of our transformations still work the same. If we know how to identify them from the last video, we look at this number here, we see that it is not negative, therefore it's not a reflection, but 2 is bigger than 1, so we do have a vertical stretch by a factor of 2. We look underneath the radical and we see that we're not adding or subtracting a number from x, so we haven't moved it left or right. However, on the outside of the radical, we do have this minus 2 at the very end. And so we would say this went down 2 units. And so these are the only two transformations that we have present. We go to y equals and we type in our function. We do 2 math cube root, then times x, scroll out from under the radical, minus 2. We graph this, and we see that our stretch is definitely there. This is a lot taller than the parent function, and it's been translated down 2 units. So let's find all of our lattice points. So we can go to second and graph. And so our first lattice point is -8, -6. So all the way here at -8, we go all the way to -6, which is right there. The next lattice point we have is -1, -4, which is right there. The next point we have is 0, -2, which is right there. The next point we have is 1, 0, which is right here. And let's see if we have any other lattice points. And we have 8, 2, which is right there. So that should be enough points to kind of get an idea of what our graph looks like. And if we connect these with a smooth curve, then we get a function that looks like this. And wow, that was a pretty good one. That's our graphed function. And so there we go. And if we compare it with our graph, I think that's pretty accurate. All right, let's look at the next one. All right, so this is not a negative number out front, so we don't have a reflection over the x-axis, but it is a number that is less than 1. 3/4 is, in decimal notation, is 0.75. So this is a vertical shrink by 3/4. Next transformation we have is this -2 here. So again, from our transformation page, you should recognize that as going right 2 units. And the next one we have is this -1, which means that we go down 1 unit. So we clear out our previous function, and we can type in 3 divided by 4, math, the cube root of x minus 2, scroll from under the root, and then -1. And when we graph this, it should look like this. So let's see what our lattice points are. We go second and table, and let's start all the way at -8. And ooh, it doesn't look like we have much of any lattice points. So, okay, so we have 2, -1. So we do have that point. We have 10 and 0.5. 10 is already out here though, and 0.5, I mean, if I try to approximate that, it's probably like right here. It's pretty flat. Oh, not quite. Probably somewhere out there. And let's see. Okay, we have maybe not other non-lattice points. So we have -6, -2.5. So -6, -2.5 is going to be right there in between -2 and -3. And yeah, that's all of our even nice points. So let's try to approximate some of the others. Okay, we have -1 0.75 at 1. So 1 -1.75 is going to be about right here. And we also have -0.25 at 3. So at 3, -0.25 is about right there. I just realized that over here, this is a positive 0.5. So this point is actually not supposed to be over there. It's supposed to be translated up a little bit. It's positive 0.5. So that makes a little more sense. That's about right there. But that's all the nice points that we can graph. But we do have 5 of them, so we got a pretty good idea of what it should look like. And if we connect this with a smooth curve, it's pretty flat. But it looks something like that. And so we have our graph. And if we go back to what our graph actually looks like, that's decently accurate. And that's good enough for our purposes. All right, let's look at number 201. All right. So let's see, we can clear that. Let's look at our transformations. This is a negative number here. So we do have a reflection over the x-axis. And this 1/2, we can ignore the sign. 1/2 is less than 1. So we do have a vertical shrink by 1/2. And then this +6 tells us that we're going to move to the left 6 units. And we don't have a k value, so we're not moving up or down. We type this into our calculator, and we have -1 divided by 2. Go to math, scroll down to cube root of x plus 6, not 3, 6. And our graph should look something like this. So let's check what our lattice points are. Okay, starting at -8. Okay, well we have -6 and 0. Okay. And the other lattice points, we have 2, -1. Any others? No. Okay, so let's try to approximate the others. So we have -7 and 0.5. It's going to be right there, halfway between 1 and 2. And we have -5 and -0.5. So at -5, we have this point right here. And let's see if we can get something near 8. Okay, well, at 8, we have -1.2. That's almost a fourth, but not quite. But approximating that as best as we can, probably something around, nope, sorry, wrong spot, -1.2. So something around there. And so now we just try to connect our line, or connect our dots with a smooth curve. And we get something that looks like this. This one's hard to draw because it's so flat. I'm trying not to give any curvature to it. But looks something like that. And so this is our graph. Let's look at this next one. So this is a negative number out front, so it is a reflection over the x-axis. Next, we have 2/3, so we can ignore the sign, but 2/3 is less than 1. So this is a vertical shrink by 2/3. And then this +5 means that it got moved to the left 5 units. We type this into our graphing calculator. We have -2 divided by 3. We go to math, cube root of x plus 5, and let's see what our graph looks like. Okay, similar to the last one. I don't think this one's going to have any lattice points, but let's see. Well, it'll probably have one, but yeah, we have one. We have negative 5, comma 0. So we have this point here, but everything else is not really. Negative 8, we have 0.96. That's pretty close to 1. So I'm going to put it like right under 1. And at negative 2, we have negative 0.96. So pretty close to negative 1 at negative 2. So I'm going to put a dot right there. Let's see what else we can get. Okay, this is a nice one, relatively. 3, we have negative 1 and a third. So at 3, negative 1 and a third is approximately right there. And around 7, we have about negative 1.5. So about right there. So that's as many points as we can reasonably make. If we go back to the point over here, we even have at negative 6, we have 2/3. It's about right there. And at negative 4, we have negative 2/3, which is approximately right here. So we have an idea of what this should look like, and connecting this with a smooth curve, we get something that looks like that. And comparing with our graph, I'd say that's pretty accurate. All right, so we only have 2 more for this video. Let's see. So this is not a negative number up front, so we don't have a reflection over the x-axis. However, it is a number bigger than 1, that is a 3. Therefore, it is a vertical stretch by 3. Then we have this minus 2 here, which means that we move to the right 2 units. And this plus 2 at the very end means that we move up 2 units. So let's type this in. We have 3 math cube root of x minus 2. Scroll from under the root and then plus 2. Graph it. Okay, pretty good idea what this should look like. And let's see what our lattice points are. Second graph. And first lattice point we see is negative 6, negative 4. It's going to be right there. Next lattice point we see is all the way over here. We have 1, negative 1. What's positive 1, negative 1? Okay. Right there. We have 2, comma 2. It's right there. Then we have 3, comma 5. Which is right there. And 10, comma 8 is another one. Approximately over here. No, right here. And that actually should be enough points to approximate this and graph it. So we have one branch that looks like that. And one that looks like that. And so comparing to our graph, looks pretty accurate. Last one we have is we have a 4/5 right here. It's not negative, so we don't have a reflection. But 4/5 is less than 1. So we do have a vertical shrink by 4/5. Next up, we have this +1, which means that we move to the left 1 unit. And this -4 on the outside is going to move down 4 units. So let's put this into our graphing calculator. Let's figure that. We have 4 divided by 5, math, cube root, x plus 1, scroll from under the root, -4. We graph this, and we have that. So I suspect we're not going to have a lot of lattice points, maybe only this one right here. But let's see what our table tells us. So as expected, we have one at -1, -4. So we do have one right there. However, everything else is not very fun to approximate. But let's see, we do have this one right here. This at -3, we have -5.008. That's basically -5. So I'm going to treat it like a lattice point at -3, -5. And similar thing happening over here at 1 at negative and 1 comma -3. -2.99 is incredibly close to -3, so I'm just going to treat it like a lattice point at 1 and -3. And let's see about anything else. Okay, that one's close-ish, close-ish. Well, -2.336 is pretty close to -2 1/3. So I'll graph that one at 8. -2 1/3, approximately right there. And let's see about on the other end. We have at -8, -5.53. That's pretty close to -5.5. So I'm going to put that one at -8 and -5.5 is approximately right here. So we have as many lattice points as we can reasonably make. And now let's just connect those with a smooth curve. And we have that. So not my best graph. I'm no artist. But it looks something like that. And so that concludes this section over graphing. This is kind of the process that I do when well, this actually is the process that I do when I'm graphing these. Of course, it takes longer for me to explain this than to actually do it, and hopefully it's the same thing for you. But yeah, I just wanted to make sure that I explain all of my steps thoroughly. But that's all I have for you today, and so thank you for watching.